Welcome to part 2, graphing these functions, cosecant and secant function. We're going to graph number 3 right now. Used to be number 2, but I guess 2 was too hard, so I decided to call it number 3. Haha. Alright, so to graph this function, it's the secant function. Again, we're not going to really graph secant. Remember, secant of theta is really 1 over the cosine of theta. So what we're going to do is we're going to graph the cosine curve instead. Our period's the same, it's 2 pi over b, so 2 pi, b is 1, so it's just 2 pi. The step, again, we're not going about the step, but we do have an amplitude, okay, and it's -1, so that's going to flip our cosine graph, okay. Our phase shift, we do have a phase shift this time, it's negative pi over 6, so remember that's left 1 tick mark. To get the asymptotes, again, we're going to get those from the graph, especially because of our phase shift.
This is a reminder that there is a meeting scheduled for all special ed.
There is no vertical shift in this one, so that makes it a little bit easier for us. So we're going to graph our cosine graph. Remember, cosine starts at 1. So when I graph it, 1, 2, 3, 1, 2, 3, 1, 2, 3, there's pi. Backwards, 1, 2, 3, 1, 2, 3, there's negative pi. 1, 2, 3. So I'm just going to sketch my cosine graph like so. Just sketching it. Remember, we're only going to dash it. Okay, I'm not even going to dash it yet. I'm going to do my transformations first. Everything gets moved left 1 and flips. So left 1, flip, goes to -1. Left 1, flip it, just stays. Left 1, flip it. Left 1 stays, left 1 flip to -1, and you can probably already get to the pattern if you need to, and that's fine. Left 1 flip it, left 1 stays, left 1 flip it. And I'm going to sketch this. This is, remember, I'm not going to draw it in fully, I'm just going to dash it, because remember, I'm not really graphing my cosine. See, that would be my cosine curve from the last test, but we're not graphing cosine, we're graphing the secant. So next what we do is we draw in our asymptotes. Anywhere it crosses, there's my midline. Find your midline if you need to. And we're going to graph those. There's our asymptotes. Here's an asymptote. Here's an asymptote. And here's an asymptote. And then we'll look for our peaks and valleys. There's a valley. So and I'm going to draw the asymptotes. So in blue is our function. Very easy to do. Alright, so to get our asymptotes, I'm just going to go in and count. Ready? If I count over 1, 2, that's over 2 tick marks. So my asymptote is going to be x equals 2 pi over 6. That's my first asymptote. Or we just say pi over 3. So to get all of my asymptotes, so there's my first asymptote. So to get all of our asymptotes, we're going to reduce that pi over 3. Again, they repeat every pi units. So that's plus or minus 2 pi k. And there is our equation. Let's get our domain and range. The domain is going to be, remember we said this, it's going to be all x's such that x cannot equal our asymptotes. Very easy to do. The range, it's going to go from negative infinity to -1, and it can include it, or we start at 1 and go up towards infinity. And there's our domain and range. Very easy to do. Alright, let's take a look at the next one. Here's number 2. It's a cosecant graph, so let's go ahead and graph this one. So, again, we're not going to graph cosecant. Graph this one is cosecant of 2. Remember, we're not going to graph cosecant. We're really going to graph the sine, because remember, the cosecant of theta is really 1 over the sine of theta. So everything is kind of done the same. To get our period, we're going to get 2 pi over 2, because our period, our b is 2 now. That gives me pi. Now, if you notice, our period is half of what the 2 pi was. So you can almost kind of guess what the asymptotes are going to be in this case, because they're going to be about half. So instead of repeating every pi, it's going to repeat every pi over 2. Now, we're not going to worry about the steps. The amplitude is 1. Don't have to worry about that. We do have a phase shift. It's going to go right pi over 3, or right 2 units. We do have a vertical shift 3. That's negative 3, so it's going to go down, right? And that's our midline. So when I graph my sine curve, we got to be really careful. We have a period shift. It's going to repeat every pi units. 1, 2, 3, 4, 5, 6. So sine starts here and it's going to end here. Remember, pi would normally repeat to here. So our sine is now being kind of compressed. So now we're going between. It's going to hit it again. And it's going to be up here and down here. So I graph. So there's my sine graph. Right there. And there's my compressed sine graph. Remember, it goes up and down. And I can kind of continue the pattern. Up here, back to 0, down, back to 0. And if I continue the pattern, there's negative pi, we can go all the way. So this is what our sine curve would look like with the compression, with the period shift change there. So to graph this now, we're going to go ahead and do our transformations. Everything goes right 2, down 3. Right 2, down 3. 1, 2, 3. Oh, yucky. Right 2, 1, 2, down 3. 1, 2, 3. Oh, yuck. Right 2, 1, 2, down 3. 1, 2, 2, 3. Right 2, 1, 2, down 3. 1, 2. Oh, look, this is off the charts fun, but we can get an idea of what it looks like. And if you want to, you can kind of continue the pattern a little bit. Right 2, 1, 2, down 3. 1, 2, 3. And for the most part, the pattern is going to be kind of similar. Right 2, 1, 2, down 3. 1, 2, 3. Right 2, down 3. Right 2, down 3, way down here. Right 2, down 3. Right 2, down 3. 1, 2, 3. And you can verify this, but you can just kind of continue the pattern. It looks like about every 1.5. Okay, and there's my sine curve. And I'm not going to go here too. Okay, now I'm going to do this lightly in red. This is my sine graph. Okay, there's my sine graph. So I draw my midline. There's my midline. Remember, what the midline is going to give me is where my asymptotes are, wherever it crosses. So here's an asymptote. Here's an asymptote. Here's an asymptote. A little harder to see, I hear you. Here's an asymptote. This one takes a while to master. Here's an asymptote. Here's an asymptote. Here's an asymptote. Here's an asymptote. There we go. And so when we graph these, right, there it is. Look for the peak. There it is. So I'm going to go up. And on the other side we go down. We go up. We go down. We go up, we go down, and we go up. And there we go. So there's our function. So let's go ahead and get the equation of our asymptotes on this one. So let's go ahead and get one asymptote, okay? To get one asymptote, I just count. I'm just going to find it. 1, 2. It looks like I had to go over 2 pi over 6's, okay? So that's, of course, pi over 3, just like the last one. But now where do they repeat? So now I want to take a look. Where do they repeat at? Let's take a look. Where's my next asymptote? 1, 2, 3 more. So it repeats every 3 pi over 6 or every pi over 2 instead of every pi like the last ones. So when I write my equation, it's going to be x equals pi over 3, my first asymptote, plus or minus, when do they repeat? Every pi over 2, and we add a k to it. All right. So what I would like you guys to do is to go ahead and try number 4, the last one, on your own. See if you have any questions over it, and we'll go over that one tomorrow in class. Thank you. Bye-bye.